Hello and welcome to Pep Talk with me, Mr. Pepperell. In this episode, we're going to look at the discovery of the atomic nucleus. By the end of this video, you should be able to tell me how the nuclear model of the atom was established, why the Plum pudding model was rejected, and why the nuclear model was accepted.
So this story is a fantastic example of how new data can completely change science, and I think it demonstrates that scientists are always willing to throw away their old ideas in the light of new evidence. Up until 1914, scientists only had a very limited knowledge about the structure of an atom. They knew about the negatively charged electrons, they knew that there was some positive charge involved as well, but they didn't know how this positive charge was arranged. The commonly accepted model of that time looked a little bit like this. What you had here was an evenly spread sphere of positive charge, so this whole area here is all positive, and then they also thought that the negatively charged electrons were dotted about inside this area of positive charge, just like the raisins are dotted about inside a Christmas pudding. And for that reason they actually referred to this model as the Plum pudding model. And scientists were happy with this as there was no evidence to suggest anything different. But then along came Ernest Rutherford, who we previously found out he discovered there was more than one type of nuclear radiation. He found alpha and beta, and Rutherford realised that he could actually use the positively charged particles he'd found to investigate the structure of the atom. Now, I don't know if he actually said this, he probably didn't, but this is what he suddenly thought to himself, that he could use these alpha particles to find out what was inside an atom. And he asked two of his assistants, a guy called Hans Geiger and another one called Ernest Marsden, to work on the problem for him. This is the experiment the two assistants set up. They got an alpha source here and they placed it inside a lead-lined container, just with a small hole on one side of it. Now, the alpha source is obviously emitting alpha particles in all directions, but they couldn't penetrate through the lead, but they could come out through the small hole. And what that produced basically was an alpha beam. They put a piece of gold foil in front of that, and on the other side of the piece of gold foil they positioned their alpha detector. What they then did was move their alpha detector about to different angles, and they recorded the number of particles that were detected at each position. Now, the researchers were really surprised with what they found. A majority of the alpha particles just passed straight through the gold foil, and they also found when moving the detector, the greater the angle of deflection, there were less particles. So the further round they moved their detector, they started to detect less particles. But the really surprising thing they found was that about 1 in 1,000 of their particles was deflected through an angle of greater than 90 degrees. That basically it bounced straight back off the foil. And they couldn't believe this. Rutherford compared it to firing a cannon at a piece of tissue paper and having the shell bounce straight back at you. Using his knowledge that alpha particles were positively charged, Rutherford came to the following conclusions. Firstly, he decided that the nucleus at the centre of every atom must be positively charged because it repelled his positively charged alpha particles, because like charges repel. Secondly, he decided the nucleus must be smaller than the entire atom because most of the particles pass straight through the foil. His final conclusion was that most of the atom's mass was in the nucleus. With these conclusions, Rutherford was able to predict the proportion of particles that would be deflected from any angle, and when he tried this out experimentally, it proved his prediction was correct. From his results, Rutherford then calculated that the nucleus must be really small. In fact, he calculated that the nucleus must have been 100,000 times smaller than the entire atom. Now, that's a lot of information, so let's just recap with this image, because for the exam, you're going to need to be able to understand and explain actually what's going on here, So we've got our alpha source over here firing particles at our sheet of gold foil, and I've actually shown the individual atoms here. Now, firstly, most of our particles pass straight through. So the particle here is just passing straight through the foil and carrying on in a straight line to the other side, as expected. And this shows that the positive charge of the atom must all be in one place. There's no positive charge just here, otherwise this positively charged particle would have been repelled. Secondly, we can see that some of the particles are deflected as they go through the foil, and they change the course that they're on. This is because they're passing close to the nucleus and the positive charges repel, and it deflects the particle to go down a different path. Finally, a very small number of particles actually rebound from the foil and deflected by an angle of more than 90 degrees. This is because they directly encounter the nucleus, like charges repel, and it bounces those particles back. So in the exam you need to be able to look at a picture like that and explain what's happening to the three different particle tracks that we can see there. So that's the end of our history lesson for today, basically. The plum pudding model that had been around for ages was rejected, it was out, and Rutherford's new nuclear model was accepted, and it was accepted really quickly for a number of reasons, okay? Firstly, it was accepted because of the experimental data produced, the experimental measurements of Geiger and Marsden, Rutherford's two assistants. The new nuclear model also helped to explain radioactivity in terms of changes to unstable nuclei. And finally, the nuclear model also predicted the existence of the neutron, which was later confirmed experimentally. So why did they chuck out the plum pudding model? Because they had new, better evidence which was supportive of the nuclear model.
So that's everything we need to know about Rutherford and the discovery of the atomic nucleus. Any problems with that, don't hesitate to tweet me at Mr_Pepperell or email me and I'll get back to you ASAP. Thanks for stopping by.